Okay, so today is lesson 111. This is the end of unit 1 finally. It's over the greatest integer function. We touched on that last week when we did the characteristics of those 7 functions. Remember, the last was the step function. That is the greatest integer function that we're looking at more specifically today. So you're going to use your calculator a little bit, the one that hopefully you have from the school that I checked out to you. And we're going to do some things with step functions. So here we go. Okay, so we're looking at lesson 111, greatest integer function. And we talked a little bit about this last week when I was doing the lesson with the 7 parent functions and characteristics. And so this was our step function. So the greatest integer parent function, the greatest integer function is denoted by double absolute, it looks like double absolute value lines with an x inside. Okay, so 2 lines, x, 2 more lines. It is defined as the greatest integer less than or equal to x. So let's start and say that x over here, 0 is less than or equal to x is less than 1. So when x is between 0 and 1, the greatest integer less than or equal to all those numbers between 0 and 1, like 0.1, 0.2, is going to be 0. All right? If I go up to 1 and say x is between 1 and 2, including the 1, my answer is 2. If I go to 2, my answer is 2. If I go up to 3 here, less than or equal to x, less than 4, answer is 3. If I go below 0, for example, negative 1, less than or equal to x is less than 0, then it's negative 1. So negative 2, less than or equal to x, less than negative 1 is negative 2. And then let's do one more here. Negative 3, less than or equal to x, less than negative 2 is negative 3. So when I'm at negative 3, my answer is negative 3. This is a closed circle going across to an open circle. Closed circle, open circle. Our domain is going to be all real numbers. Negative infinity, positive infinity. Our range is, I'm just going to write the set of integers. We talked about this last week. All right. My output is always an integer. It's negative 5, negative 4, negative 3, etc. all the way to infinity. Negatives and positives. Characteristics. Okay. This function is discontinuous at every integer. It jumps to the next level at every integer. So if I get to 1, it jumps. If I get to 2, it jumps. Discontinuous at every integer. My x-intercepts are going to be all x's in the interval from 0 to 1. All right, including the 0, not including 1. My y-intercept is 0, 0. That point, that single point, 0, 0. So now we're going to look at using the calculator here, and hopefully you got a calculator when you picked up stuff for school. Okay? Because the greatest integer function is discontinuous at every integer, it is an example of a step function. The greatest integer function is found on the calculator under Math Num 5 integer. All right. So if you turn your calculator on, the math button, move this so you can see it better. Math button right here, we're going to press math. And then we're going to press, you can see we have different things here. It says we're on math right now menu, but we want the num menu. So I'm going to press the right arrow to get to the num menu. And you can see the 5th one down says int. So you can either press 5 or you can just arrow down until we highlight int and then press enter. Either way. So I have int, and let's just do one or two of these. So if I put in 3.4 here, I'm going to do int of 3.4. Close my parentheses. All right, press enter, and it tells me the answer is 3. So I can, over here, I can say, all right, 3.4 equals 3. And then we can go back through that same process, but even easier, if you hit second enter, it'll retype the last thing you have, and then you can backspace, and I can put 8. I'm going to delete a couple digits there, so I have integer 8, press enter, and I get 8. All right. So I'm going to pause the video. I'm going to let you do those last two, see what you get. Then we'll move on. All right, so -8 should be -8. -1.5 should be -2. Okay? Think about the number line. Because it's easy, you just truncate off the decimal when you're positive, but if you're negative, think about the number line. If here's -1 and -2, I'm sitting at -1.5, I'm going to go to the first integer to the left, that's going to be -2. All right, so here is where we really get to it. Number 5, suppose the cost of a telephone call from Los Angeles and London using Acme calling card is $1 for calls less than 60 seconds, and 25 cents for each additional minute or portion of a minute. Okay, this is a little bit out of date, but bear with me. Greatest integer function can be used to create a model for the cost of the call. Make a table and graph the function for 0 to 5 minutes. All right, so here's going to be our time in minutes, and here's going to be our cost in dollars. Okay? So from 0, I'm not going to, if I don't have any time, it'll be 0 cost. So I would say 0 less than, not less than, equal to. 0 is less than t, and it has to be less than 60 seconds, it says. So less than 60 seconds, it's going to cost $1. For the next minute, from 60 seconds up to 120 seconds, in other words 2 minutes. Actually, we're putting minutes here, sorry about that. So let's change this to 1, let's change this to 1, let's put this to 2, sorry about that. Okay, 0 to 1, it's $1, 1 to 2 is going to be, we add on a quarter, $1.25. 2 less than or equal to t less than 3, we add on another quarter, $1.50. 3 less than or equal to t less than 4, add on another quarter, $1.75. 4 less than or equal to t less than 5 is going to be $2. And let's go on and put 5 less than or equal to t less than 6, $2.25. Okay, graphing that, it's going to have an open circle here, an open circle at 1 minute, and I have this step right here, $1 for that first up to 60 seconds, less than 60 seconds. Then it jumps up by a quarter. Notice each line here represents 25 cents. So I have a closed circle to the left, open circle to the right, and it jumps up 25 cents. Then again, closed circle to open circle, $1.50. Closed circle to open circle, $1.75. Closed circle to open circle, $2, and then finally at 5 minutes, we'll go up to 6 minutes, it's going to be $2.25. All right, so let's talk about what the function's going to look like. First thing I notice is that instead of jumping up by 1 unit each time, we're only jumping up by 25 cents, 1/4 of a unit. And so that's going to, what we're having here is a vertical shrink. Okay? So I have a vertical shrink times 1/4, 0.25. All right? The other thing is my first step at 0 is usually between 0 and 1, and here it's up here. It's up 1 full step here, 1. So I'm going to shift up 1 space. All right, so my function is going to be, I'm going to say cost as a function of time is equal to going to say 0.25 times the greatest integer less than or equal to t plus 1. All right? Cost in terms of t is equal to 0.25 times greatest integer less than or equal to t plus 1. So now we're going to use that to find the cost of an 18-minute, 45-second call. So 18 minutes, 45 seconds. I'm going to write that as 18 and 45 seconds is 3/4 of a minute, so it's 0.75 minutes. 18.75 minutes. So we're going to plug that in for t. So c of 18.75 is equal to 0.25 times, times greatest integer less than or equal to 18.75 plus 1. So this is going to be 0.25 times 18. Greatest integer less than or equal to 18.75 is 18. So we have 0.25 times 18. I got that handy dandy calculator still here. That's going to be $4.50 plus one more is going to be $5.50. Okay, so that's how much this 18-minute, 45-second call will cost. $5.50. All right, that's it. It's Friday. Have a good weekend. We're going to spend a couple days reviewing next week over Unit 1, and then we will have a Unit 1 test on Wednesday. So be ready for that. All right, bye-bye. All right, as I mentioned, this is the end of Unit 1, and so we'll review on Monday and Tuesday, and we will take the Unit 1 test on Wednesday. All right, so you have several days to get back to me if you have questions about anything in Unit 1. Then this would be a good time to do that. Ask questions about that. Okay? So I will have a good weekend, and I will get the review to you on Monday. Bye-bye.